Welcome back to my videos on the design, the building, and what will be eventually the sailing of this 7-meter or 23-foot Sharpie built out of Paulownia Timber. As you can see, I'm up to the stage of the cabin and getting it to a stage now which is ready for glassing, except I have to work out where all the fittings go. All the lines will run on the cabin top because I'm going to drill oversized holes for inserts that'll go into the cabin top before I glass the outside and the inside to give it the utmost strength, and there's no way I want to take risks of water getting into the Paulownia timber. So I've had to work out things like this hatchway, which I'm just about to order. It's a pretty custom made hatch made by Cule. They make hatches for the 580 class that's racing around the world right now. Their ones are rectangular. I wanted a hatch which is trapezoid, which is not beyond the skills of Cule apparently. Sorry if I'm saying it wrong. I wanted it this way because when this hatch opens on its hinges down here, when it swings open, I want it to swing 180 degrees, which is one of the things that makes them a custom hatch. They don't all open 180 degrees. I want it to miss the cockpit seating here, so it can open fully and be out of the way, because this will eventually be a seat here where you'll sit under a dodger. And if the hatch is only opening up out here somewhere, it'll really interfere in the space in the small cockpit. So that's one of the things I've had to get my head round. So there's been quite a few emails back and forth with Cule, C-U-L-E, and they've been really helpful, and it won't be cheap, but this hatch is going to really do the job. So let's I'm starting to get a better idea of the looks now. It's all very well to see what it looks like on the CAD drawings, but to see what the boat looks like in this perspective up close as it's being built is meeting my expectations. It's a high cabin because I wanted headroom, high compared to some trailer sailors, but to me it doesn't take away from the looks of the boat too much. It's, to me, a happy compromise. For those of you who haven't seen my earlier videos on the sail system for this yacht, which is based on a Lundstrom rig with my twist to it, having the wishbones there and how they work is, as far as I know, quite novel. There are Lundstroms with poles that support the sail in certain conditions, but how I've set it up, and that's how, when you're going downwind, that's how it's going to work. I'm quite confident it will work quite well, but there are a few technical details I've got to make sure I get right. There's a swivel at the top. These wishbones are quite novel in that they go past each other like this. There's a limit to their travel, but in some Lundstrom rigs they have a pole supporting the wishbones which stands up here, and some of them have rollers which, when the mast rotates and the sail furls on it, the roller is on the outside of the sail material. Some don't have the sail coming right down to the tack here, so the wishbones or booms are attached on a swivel at the bottom of the mast there. This is how I'm going to give it a go, although there is a chance that just to get the boat sailing and out on the water, I might make it a more pure Lindstrom rig by not having the wishbones to begin with and treating it like a traditional Lindstrom with sheeting that goes back to the aft of the boat. Anyway, want to go downwind? That's how it works. I've got a bit of a dilemma. Do I take all these screws out before I glass it? I was thinking of glassing up to a set of screws, removing them, sanding, glassing up to a set of screws. That's probably the conservative way to do it, because I know exactly what's going to happen. It happened with the top sides. When I take all those screws out on a day that's quite humid, the timber will expand, it'll separate from the frame underneath, and it's surprising how much it will actually create a gap between the skin and the frame. But on the other hand, I'm not too worried about it, because what I've found is at the end of the day, when things dry out a bit, it only takes a day, it'll probably pull back down onto the temporary frames underneath, and then I'll get a glass skin of get some fiberglass on, and that's the time of the day I want to do the fiberglassing anyway, because definitely the timber will be releasing air as it expands inside the timber as it warms up. So all the glassing I'll be doing will be at the end of the day anyway, when it's fully dried out and probably fully pulled down onto the frames, the temporary frames. So I'm going to take the risks. I'm going to take all the screws out, and if it's moving too badly, I can always put the screws back in, but I really do want to sand this whole surface and fair it up a little bit. Well, there you go. It's already lifted up. It's a reasonably high humidity day. I think it's going to rain, so I'm going to go and look inside and see how much it lifted up. It's probably still being restricted by those screws up there. As long as it's uniform, that's the main thing. Although the dagger board casing will restrict it. And I'd be really concerned if it dried out more on one side than the other, because it could pull the casing one way or the other. So anyway, I'm going to go and have a look inside. Oh, this is a bit funny. I'm getting a bit ahead of myself. It's a bit of a relief in a way to see what's happened. See the huge gap up there? I was stunned when I first saw it. I could fit my hand through it, just about my fingers. Oh, what? It's moved so much more than I expected. And then I looked to the side and I'd forgotten to do the sanding on the outside. I'd taken out that screw, and this pretty useless hot glue hadn't stuck to the fiberglass, even though I cleaned the fiberglass. And it's a peel ply finish, pretty rough. Hot glue really doesn't like sticking to it. So it's a bit of a relief. It may not be as bad as I thought it was going to be. So I'll take the screws out of this one. I'll put the screw back in the top of that one, and I'll see what's going on. Well, that's a relief. I've taken all the screws out in the next frame, and it's still a snug fit. Press on. Here's some examples of why I don't use glue. I joined these with glue before I started using fairing compound, and you can see where the joins are there. After sanding, the spots remain high. Just as a little aside, for those of you who haven't seen my earlier videos on how this boat will sail, what sail system it's got, this is a model which I put a lot of thought into, And the wind's going both ways in the sheds here today, but the principle is like a Lundstrom rig, when you're going downwind, the sails open up quite easily. It does it all by itself with the wind going in both directions in the shed. And it's not getting the full effect there, but that's the principle. And I'm getting closer and closer to seeing how it works. And yes, I've had to work out, will this hatch work in the way of getting in and out of the boat, considering it's not a slide hatch and I'll have to step over this every time I go into the cockpit. There'll be a big step on the inside, of course. That's where the main battery is going to go, the 48-volt lithium battery. So that's about the height of what it'll be on the inside, this board down here, and about the height of what it'll be on the outside. And it's a pretty easy step, even for a guy who's not so flexible as I used to be. So, getting in the boat. For the added security that it gives, that wasn't a great example. That's not my good leg, that doesn't bend very well. For the added security that this hatch will give, if I'm on the boat by myself and I get into a situation where I'm a bit worried about waves and following seas maybe, just waves coming over the deck maybe, and wanting to keep the boat dry, I'll just be able to go swing the hatch closed, dog it, and not even leave the helm. So that's the idea of this hatch. I don't want to be caught out. And I probably will be sailing this boat around quite a bit by myself. So it's just another thing that gives me peace of mind. I shouldn't forget to mention that yes, I will be able to sit in that space there. That's and just about every boat I've had, you quite often end up sitting there if the self-steering's going, or you're watching someone helming, or just out of the weather. So that's 380 wide there. That's the maximum I can go to make this work by when it folds. And I've measured up things, and that's about what works for me. Just got a little bit extra because this is the cutout size, so the aluminium frame will have a little bit of internal space there. So that's the standard hatch from Cule for this situation. They're all custom made, but they do make batches of them. There's 500 cut out, 500 wide at the bottom, and 850 cut out deep. So this is the only thing I'm changing is the width on the bottom for this hatch. Okay, so the blue tape represents the position of the windlass, where it will go. It has to miss the companionway when you're going through, but only just. I want to really minimize the impact of it on the inside of the boat. There'll be two spin lock triple clutches here. I might have to move them that way a bit so the angles of the line to the winch won't be too severe, but really the this line here, which will lift the daggerboard, the ballasted daggerboard, will be taking the heaviest load. The daggerboard is going to be about 250, 260 kgs overall. So that's my biggest lifting load. That's probably going to be a 10mm line. It's going to go around a Harkin cheek block there, which will be screwed through the deck and reinforcement around that. Actually, no, that's a spin lock double sheave. I've got an extra one there just in case I decide to do something a bit differently or I need it for one of the lines that go forward. But anyway, I've designed and ordered some stainless steel plates that I'll make out the lifting gear that will go, the sheaves housings they'll go on top of the daggerboard, and also this plate that'll go across the top that has another sheave in it. So the line will actually only be taking half the load of the daggerboard with its ballast. Plus, I've gone back and forwards on this so much, but what I've finally decided to do, there'll be a rectangular plate here. There'll be a hole in the front of it which lines up with one of the Cule bolts. There'll be a stainless steel 6mm bit of multi-strand 7x19 that attaches to the top of that keel bolt. Comes up straight and goes through that plate on the deck there, that 6mm plate, and it'll have some adjustment nuts on it so that when it's down it'll sit the daggerboard in just the right place so I can push the bolts through from the inside. Plus it's there to restrain the daggerboard in case this line fails or someone accidentally lets it go, although I'll be taking measures to make sure that it doesn't happen. So I'll be also having an extra cleat up for there for that reason. And maybe some kind of way of restraining, because I know of boats where, one or two, where this has happened, and it's been the type of daggerboard which gets restrained by the hull on the bottom. And you can imagine the forces. I have calculated them approximately. What the forces are of 270 kgs dropping 1.4 meters. As my friend Dave suggested, I might under these two nuts here, which a nut and a lock nut to get the height just right. Under that there may be a bit of rubber. Just take a bit of that impact out of the damage that it could do. And to some degree, I don't mind if it bends the plate a little bit to absorb some of that energy. And I've gone for a double, triple spin lock because I don't want to use cam cleats, because I had cam cleats on my previous boat, and the last thing you want to do to a cam cleat is overload them. So I certainly wouldn't be using a cam cleat for the holding up the daggerboard. But cam cleats, I'll be using clutches there for the lines that'll come off the base of the mast that will rotate the mast, the furling lines, and there'll be two outhaul lines which also come back along this path and up to those clutches. Also, up on the bow there'll be a line that goes from the bowsprit up to the top of the mast where there's a swivel, and that line is to not only raise the mast but hold it up there. I've decided finally that's how I'm going to do that. There'll be a stop that limits its travel on how you raise it on the inside of the boat. More on that later. Plus potentially there's two lines coming back from a furler that could deploy a code 0. So there could be three lines coming back from the bow. There'll be a spin lock deck and organiser down in that corner of the cabin. They'll come up, there'll be 2 double spin lock organisers here somewhere. That'll take the lines back to the cockpit. If you've made it this far, I really appreciate it. Thanks for watching, and any feedback is most welcome. I'm making a lot of decisions in this video, which you don't see, but I've spent a lot of time on the computer designing, making cut files for the stainless steel, trying to decide the final positions for things like these spin lock deck organisers, and there's a hatch on its way for the foredeck there. It's not a huge hatch. I think I'll just be able to get through it. But that's this line, of course, these lines coming off the base of the mast will have to not stop that hatch from opening. So there's been a lot of decisions like that will become more apparent when I, in the next video, start drilling holes in the deck, filling those holes with glue resin, and creating some reinforcing for some of these fittings, which could take quite a bit of load, especially that one, which takes half the load of the digger board. So there's a bit more to go on the cabin, but it's really good to be at this stage. See you next time.
Cloaked in folds of midnight water, side by side we sons and daughters.